All right, let's talk about sine. I know, you hear that word in math class and maybe your brain just kind of shuts down a little bit. But what if I told you that at its core, it's something you already totally get? It's just a simple fraction. Stick around for the next few minutes and I promise I'll prove it to you. No, seriously, that's really it. We build up these big, scary ideas in our heads, but the foundation of trigonometry is just that, comparing two numbers. It's a concept you've been using for years, you just didn't call it trigonometry.
So here's our game plan. First, we'll see why it's really just a fraction. Then we'll get the one formula you actually need to know. After that, we're going to put it to work with some examples. I'll also show you the number one mistake pretty much everyone makes so you can avoid it. And we'll wrap up by seeing why any of this actually matters outside of a textbook. Sound good? Let's dive in.
Okay, first things first. What is sine really? Let's just peel back all those intimidating layers and get right to the simple truth at its core. It all starts with this idea you already know, a ratio, a fraction. So picture a right triangle. If you make it bigger or you shrink it way down, as long as you don't change the angles, the relationship between the lengths of the sides stays exactly the same. Sine is just the fancy official math name we give to one of those super consistent relationships. So, if sine is just a ratio, the big question is, which one is it? I mean, a triangle's got three sides, right? Well, that brings us to the one and only rule you really need to memorize.
And here it is. The formula is simply this. Sine equals opposite over hypotenuse. That's it. When you see sine theta, that little theta symbol just means the angle we're focusing on right now. So from the perspective of that angle, you find the side directly across from it. That's your opposite. And you divide its length by the length of the hypotenuse, which is always the longest slanted side of the right triangle.
And this right here? This is the really cool part, the core idea. Because sine is a ratio, the actual physical size of the triangle doesn't matter at all. A tiny triangle the size of a postage stamp can have the exact same sine value as one the size of a mountain as long as that reference angle theta is identical. The angle is the only thing that determines the sine. Okay, enough theory. The best way to really get this stuff to stick is to just roll up our sleeves and do it. So let's solve a few problems together, starting off easy, and then we'll work our way up.
All right, let's start with a classic. We've got ourselves a 30-degree angle. The problem tells us the side opposite it is 3 units long and the hypotenuse is 6. Our mission is to find the sine of 30 degrees.
So how do we tackle this? Let's walk through it. First, just imagine you're standing right at that reference angle at 30 degrees, okay? The hypotenuse, that's the longest side, that's 6. And the side directly across from you, the opposite, that's 3. Now we just build our ratio, opposite over hypotenuse. That's 3 over 6, which, hey, that simplifies down to 1/2. And that's a cool fact. The sine of 30 degrees is always 1/2. Doesn't matter how big or small the triangle is.
Okay, on to the next one. This time we don't know the angle, but that's fine, because we know the sides. The opposite is 10 and the hypotenuse is 25. Let's find the sine and simplify it down.
The process here is exactly the same. We just build the fraction, opposite over hypotenuse. That gives us 10 over 25. Now, all we have to do is simplify it. What's the biggest number that goes into both 10 and 25? It's 5. So we divide the top and the bottom by 5, and we get our final answer. The sine of this mystery angle is 2 over 5. Simple as that.
All right, time to tackle one more, a slightly spicier one. But listen, don't let that square root scare you. The rules have not changed one bit. The opposite side is 4 times the square root of 2, and the hypotenuse is 8. The goal is the same as always. Find the sine and simplify. Okay, the crucial trick here is to just focus on the numbers outside the square root first. We set up our ratio, 4 root 2 on top, 8 on the bottom. Now, just look at the regular numbers, 4 over 8. We all know that simplifies to 1 over 2, right? The square root of 2 just kind of comes along for the ride on top, which gives us our final answer, the square root of 2 over 2. See, not so bad at all. Now, solving for sine x is pretty straightforward once you get the hang of it. But there is one really common mistake that trips almost everyone up when they're starting out. So let's make sure you know exactly what it is so you can just sidestep it completely. The mistake is super simple. It's just flipping the fraction upside down. For some reason, our brains often want to put the bigger number on top, so it's really tempting to write hypotenuse over opposite. But for sine, it has to be opposite on top, hypotenuse on the bottom. Always.
And this actually gives us a fantastic little trick to check our work. Remember, the hypotenuse is always the longest side of a right triangle, period.
That means the number on top of our fraction, the opposite, will always be smaller than or equal to the number on the bottom, the hypotenuse. So if you ever calculate a sine and your answer is a number greater than 1, you have definitely 100% flipped the fraction. It's an instant red flag that tells you, whoops, go back and double check.
So we can calculate it, great. But the real question is, who cares? Why does this even matter? What's the point of all this? Let's connect what we've been doing to the real world for a second.
Well, in the real world, think about an airplane landing. Pilots need to maintain this super precise angle of descent called a glide slope. And what are they doing? They're using sine to constantly calculate the relationship between their altitude, that's the opposite side, and the actual distance they're flying through the air, that's the hypotenuse. Getting that ratio right means a safe landing. And looking ahead in your own math classes, nailing sine right now is absolutely crucial for understanding bigger ideas down the road, like the unit circle and graphing wave functions for things like sound or light. It's a foundational building block you just can't skip.
So, to wrap it all up, we've kind of pulled back the curtain on sine. We've seen that it's not scary, it's just a simple fraction, a consistent ratio that compares the side opposite an angle to the hypotenuse. But that leaves one side of the triangle we haven't talked about at all. The adjacent side, the one right next to our angle. What's its story? Well, that's a question for another day.